present module, we are covering common emitter and common source amplifiers. That means my style of teaching here is common emitter and common source are similar to each other. That's why at a stretch we'll complete the two amplifiers using BJT knowledge, using MOSFET knowledge. After covering this chapter number 7, we'll pick the questions from the workbook related to common emitter and common source amplifiers. We'll cover the total workbook after this. After this practice session, we'll go to the chapter number 8 tomorrow class. That is about common collector and common drain amplifier. That is one more amplifier we have. After that, we'll do the workbook practice again. We'll pick the questions of common collector, and lastly we'll go to the common base and common gate amplifier. That is my idea. So within I think the 3 chapters we have to cover the total schedule now. So mic is not off, my friend. Voice is coming. Voice is coming. I think just verified. Voice is not coming. Voice is not coming. Crowd level. Volume on. Crowd level. Mic is off. Hello. Hello. Is it my voice is audible? Check it one time. I think I am also not getting. Crowd level. Yes, I'm getting. Full volume. No audible. No audible is coming, but what happened to my laptop? Hello? Hello? Yeah. Anyway, now I think it is coming. Voice is coming, I'm expecting. Again, I'll repeat what I said in the class. One more time, I'll repeat, don't worry. So, meanwhile, you write these topics. Today class, our new chapter is chapter number 7, we're studying. So, chapter number 7, we're studying. Now it's okay? Audible, I think? Great. It's audible, great. So today class, we're going to start, actually chapter number 7, we are going to start today. Previously we covered up to chapter number 6 called MOSFET DC analysis, and BJT DC analysis is completed up to chapter number 6. I divided now amplifiers into 3 chapters. One is chapter number 7, chapter number 8, and chapter number 9. It may take today, tomorrow, day after tomorrow sometime. These amplifiers will be completed. Chapter number 7, we have been starting our module with a common emitter and a common source amplifiers. Means my teaching methodology is at a time BJT amplifier, at a time MOSFET amplifier we are going to cover. Because in analog electronics, a common emitter amplifier will work similar to common source amplifier. So why to study separately these topics? We'll cover common emitter at a similar time, we'll cover the common source also. It will make the subject easy and it will become a lucid manner we can see the concepts. Okay, in a simplified manner we can see. So today our target is a common emitter and a common source amplifier. In the complete amplifier subject, common emitter is the biggest concept. The remaining common collector or common base are very simple. They take less time for us. So today our journey will start at 8 o'clock. Now we are starting. Today up to 4 o'clock. Maybe maximum I can cover only up to here. Tomorrow also it will take some time extra about these 2 modules. Means tomorrow, after some time we are going to cover the total theory analysis. After that, workbook practice will be there based on this. And next we will start the common collector and common drain amplifier tomorrow class only. Day after tomorrow we will go for common base and common gate. This is our story. So total 3 chapters. We cover the complete entire module about amplifiers based on BJTs and MOSFETs. I'm expecting these are the 6 topics. So please note down in your notes. First, what I'm going to teach is BJT amplifier models. First, we'll try to understand today. How many models are there? What theories they are applying? Which theories advantage at what time you have to use? These are all things a student should get a grip in the subject. Then only he is good in doing amplifiers. The main trouble for the student is not understanding these models. From which model, how to apply. If I see a question, then when to apply hybrid parameter model, when to apply RE model, when to apply RPi model. Nicely, we are going to study these modules today class. The 3 modules to study only will take nearly 4 hours of time. Other things are easier. Only model study will take time today on BJT class. So today first starting class will be based on these 3 model analysis. After understanding that models, the next presentation will be MOSFET amplifier model also will study. But MOSFET does not have so many theories. It has its own theory called field effect transistor model theory we have. So it will take hardly 10 minutes to understand. But BJT to understand it takes nearly 4 hours. That models. But field MOSFET takes only 10 to 15 minutes max. So this is about model theories. Next our target is today the designs called amplifiers. Common emitter, common source, bypass systems. We have one analysis. This is bypass, and we have one more style is unbypass. There are 2 different amplifiers in common emitter. One is bypass amplifier, one is unbypass amplifier. I'm going to teach this class in 2 variety of modes. One is VA equal to infinite case. I'll explain you the amplifier characteristics. VA not equal to infinite. Yesterday I think you have seen in current mirror techniques. VA equal to infinite means theoretical study. VA not equal to infinite means early voltage is not equal to infinite means we are studying practically the amplifier. So examiner can ask you with infinite, without infinite questions. That's why we'll try to have 2 different visions. In the same manner, unbypass also will study like that. These are the main topics to study. After that we have 2 separate modules actually. These are separate chapters which I kept in this module only to cover. One is active load technique which widely used in integrated electronics. Indirectly we have seen in previous class in CMOS inverter techniques we have seen. We have replaced a resistor load with respect to a transistor load. That loads we call it as active loads. And different variety of active loads, how to design and how the equivalent resistances we have to find out. That beautiful knowledge is called active load. You'll get a good number of questions based on active load in gate exams. This topic is very important. And last topic is based on frequency response. They'll ask you the questions. Okay? The total entire frequency response based on BJT and common source amplifier. Who will study this entire module, whatever I'm teaching in the class. If the notes, if you believe correctly, whatever may be the question given by the examiner, any question you can solve. That promise I can do for you. A very valuable content will come in the notes step by step. Let us understand this total course. Today we'll do the work on this 8 to 4 we have the time. Tomorrow also it will take some time to cover these 2 modules. After that we are going to further workbook practice. So tomorrow by mid time, like 1 o'clock or 1:30, we are closing common emitter and common source. That much time we are spending the time only for 2 amplifiers. Common emitter and common source because 95% questions in your books will be common emitter and common source. Hardly 5% questions will be common collector and common base. So we are not showing much interest about common collector and common base. The main important subject for us is common emitter. That's why we'll take a valuable time for it to understand this course. Okay? So I hope you should require patience to understand the steps step by step. After that, at the end of my short notes, you feel that only within half an hour this complete module will be in your mind. So if you want to get like that, the trick only within half an hour how to bring total concepts in our mind. First you must be able to understand each and every step. Okay, to understand the formulas, I do derivations also today class. Derivations are not required actually, but as you are a basic student, you are studying the fundamentals. Derivations if I take, you'll understand how they approach and how the formula came. It will be stand for a long time for you. That's why it will take time to teach step by step in the classes. At the end, half an hour is enough to study the complete concept. Okay, that is nothing but video is also not playing. So can you confirm that? Yeah, the testing is nothing but lecture 14A, I think. Let us make it correct. Don't worry. You have given the information to me. Today by evening, it will be re-uploaded. Don't worry. Maybe some mapping problem will be there when you are sending. So let us make it correct once again. No problem. Great. So please note down these 6 topics. Today we'll start our journey. Without wasting our time, we'll start our journey. Today what I'll do is this one topic. The first topic is a big topic actually called hybrid parameter model. Complete amplifier analysis. We'll study with hybrid technique. Remaining things are by RE models. Just only model representations are enough. Any one theory you have to study the complete picture. So hybrid theory will take some time to understand. Remaining theories will take less time. What I'm thinking is before the break, we'll cover one module at least called hybrid parameter model. We'll complete. After that, I'll use a break for you, half an hour breakfast. After that, we'll continue the remaining course. Okay, that is my idea. Hybrid model itself will take nearly 1 hour class. Let us start the first journey now. Okay, Vinay, I understood. Lecture 14A will be re-uploaded. Don't worry. So please note on it. We'll start our class today. I've given sufficient time for you to write all these things. So note down properly. Today, have a good patience to understand each and every step in a nice manner. Okay. Don't tell that sir, so many formulas is any baat karna. Let us understand the flow chart. Okay, each point what is the meaning of that, like that. Then there is no meaning of formulas in the subject. All are easy and applicable concepts to in your problems. You can apply very easily. So don't see the formula stories as any baat karna subject. Okay. Formula what is the birth of that? If you can learn like that, anything you can create yourself in the exam point of view. That will not take much time. The persons who will by heart it, they'll have more number of formulas. Who will understand it and do it, they'll have less formulas. That is the difference. More formula, less formula. Difference is that. Who will understand and do it, that is the meaning called less formulas in your mind. Okay. Everything if you by heart it, mug it off, then automatically a lot of formulas will be there in analog electronics. So let us start our course today. So the first course I'm starting today. Keep the heading BJT amplifier models. BJT amplifier models. In this, we are going for the first topic, subheading A, called as hybrid parameter model. That is called H parameter model. H parameter model. This is our today first class. This is our first class today. H parameter model. Okay. First, a simple reason. Why should I take this theory? Hybrid parameter model. Why should I take? In networks course, I think when you study, there are two-port networks, correct? In two-port networks, we have Z parameters will be there, Y parameters, hybrid parameters, G parameters, ABCD. So many parameters are there. But BJT is a current amplifier. That's why matching two-port network theory they understood the research people as a hybrid parameter theory in electronics. This theory will be the matching for BJT devices. MOSFET theory is different for the another two-port network because the BJT is a two-port network device and the MOSFET is also a two-port network. Means any transistor is a two-port network. Let us understand this theory now, hybrid parameter theory, and how to replace this model, these parameters in your BJT model. That is our course today. Let us understand the basics of hybrid parameter theory from networks course. So what is hybrid parameter? H parameter theory first we'll understand. Just we'll have a small basics about H parameter theory. If you come to network theory, hybrid parameter theory, how to define it? This is a black box we can say in networks. There is no meaning about this box. It's a black box they'll call. It will have two input and two output terminals. In networks course, this is a way of representation for it. And assume that this model is a hybrid parameter model called H parameter. We have two voltages, V1 and V2. In networks course, always this current indication they show inward for this black box. So this is called networks indications. Because that box does not have any meaning. But in our analog electronics, that box will become BJT or MOSFET. So in networks course, there is no meaning. That's why the currents will never show output. We show inward to the boxes. This is called conventional directions in networks. If you take V1, I1 will go inside. If you take V2, I2 will go inside. These are called conventional current directions in networks. Let us write here what is the hybrid parameter concept is. The V1 of input port is a function of I1, V2, and I2 is a function of I1, V2. Actually, this is the way how to write the hybrid parameters equations. The only thing is one input port parameter, one output port parameter depends on one input and one output like that. So V1, I2, cross mark you do it. These two parameters are dependent parameters based on independent parameters called I1 and V2. That mixing we call, this is called mixing parameters. We call it as hybrid parameters, which is a special parameters in two-port network theory. Hybrid is nothing but mixing we call. We are mixing V1, I2 in terms of I1, V2 as a cross mark. That is the functions I have written here. V1 is a function of I1, V2. We can define the voltage V1 like that. And I2 is a function of I1, V2. Whenever you know these functions, we can write the equations now. Two-port network equations. V1 is equal to Hi into I1 plus HR into V2. And I2 is equal to HF into I1 plus H0 into V2. These are the most important two-port network equations. The only thing is, in place of I1 and V2, I kept some product values of these parameters in the class. And I defined V1, I2 like this. First letter is HI I have taken. Second letter is HR. Letter number 3 HF. And letter number 4 is H0. There are 4 letters we have taken. Let us understand each letter meaning is what. What do you mean by that parameters? Okay. Which will be used for analog BJT device modeling. So to make that model first at least, what is the parameters you have to understand in the equations. So if I take case 1 here, you go for case 1 study. What I'll do is, in case 1, your V2 will make it as 0. In two-port networks, what is telling is, if output port, if you neglect, you can find out the input parameters. If you neglect the input port, you can find out the output parameters. Like this, we can do it. So output port neglect, so V2 I made it as 0 in the class. If you make 0, this total terms will be removed. So V1 will become Hi into I1. This is the first equation we'll get. V1 is equal to Hi into I1. Please note down parallel with me. I will not use more time to write today. Okay? So that please note down parallel with me. They are very simple and easy from the basics of networks. So V1 is Hi into I1. You listen and write down. Okay? You listen and write down. So what is Hi here is? Hi is nothing but V1 by I1 is called. So this is the definition of Hi in the class. What it means in analog electronics, when I say V1 by I1, input voltage by input current, in analog course, the language we can call this as input impedance we can call. Input impedance. Which is defined as ZI we can call. So it is defining about input impedance of your system. Okay? That is the meaning called HI. Now one word you should have a good knowledge like this. HI is a two-port network knowledge or two-port network theory language. If you convert into our analog process, we call HI in the exam point of view whenever they give. We feel that it is the input impedance of your amplifier or input impedance of your transistor. अनन्या ऐसी बात नहीं करना यार. I2 V2 as a function of V1 means it will go to some other two-port network theory. Okay? हमको here hybrid चाहिए. Whenever you need hybrid parameters, the logic here is it's a crossmark theory we call. It's a crossmark theory. This is V1 actually. This is I2. These two parameters will depend on I1, V2. This is the way how to remember hybrid technique. V1, I2. You can have a color otherwise. These two are V1, I2. These two parameters exactly has to depend on these two parameters. So whatever you like, we should not do. Hybrid means this is the only meaning we have. So what is this? A green line indicates. Here green line. Here green line indicates. This green line indicates they are dependent parameters. These are dependent parameters we can say. And that yellow line represents independent parameters. Independent parameters. So we don't need other parameters knowledge today class. I want to know exactly hybrid parameter indications. So whatever you like, we should not do here. Okay? If you do like that, there will become some other two-port network. Exactly if you want hybrid technique, these two things should be remembered for you. V1, I2 are dependent on I1 and V2. So you can write like this in the notes. It will be a shortcut view for you. Unnecessarily don't do whatever you like. Ananya, for you only I'm telling. Okay? You're telling that I2 and V2 as a function of V1. If you do like that, it will become some other two-port network theories. Hybrid means we need mixing. That I done nicely in the class. So what about the next parameter we want? HI, this equation is over. Second equation is I2 is equal to HF times of I1. This is the next equation. This is your second equation. I2 is equal to HF into I1. At that time, V2 is 0 again. Now what is HF here? We are getting is HF is nothing but I2 by I1 we got. So in analog electronics, whenever you have output current by input current ratio for your device, we say that is called current gain we call. And the current gain can also be called forward current gain. Because forward means output by input, we call it as forward. Suppose you got the formula as I1 by I2, not I2 by I1, then we call it as a reverse current gain. Input by output ratio if you get, it is called reverse current gain. Output by input if you get, it's called forward current gain. That's why this F letter indicates a forward. It's a forward current gain. Here HI I have written because it is defining the input impedance. So like this you can indicate the concept. So this is telling about forward current gain. It is defining for you. It is defining as forward current gain. So we got two definitions in the class. One is HI. So highlight these two formulas, which is important for our courses, these ideas. HI is V1 by I1, which is input impedance. Next formula we got HF, that is I2 by I1, forward current gain. So these are the two formulas we have been completed in the course. Yeah, Jahnavi, your statement is correct. Okay. If you are not distinguishing these two colors, I'll write another color for it. Let us write this by somebody saying you are not distinguishing, that's why I'm writing. I take this as red color. Independent is red color I have taken, now you can distinguish. Okay. Color you can see. Some students I think color they are not visualizing correctly, yellow and green. So I change it to red color or pink color you can see. It is not red, pink color I think. So this is about H1 and HF. Nicely complete the part. The remaining concept we complete now. The remaining concept is two more parameters we'll try to analyze. The two more parameters is case 2 we can take, second case. In case 2 we'll make it as I1 is equal to 0. So input port current I'm making 0 in the class. So when you make input port current 0, then output parameters we can discuss in the class. That means this currents you make it 0, we get the other formulas. The first formula we are getting is V1 is equal to HR into V2. HR is equal to V1 by V2. Have you seen that? It is also coming like a gain formula for us, but the gain formula is coming as input voltage by output voltage. Whenever the ratio comes input by output, we call it as reverse gain. Whenever we will get the output by input, we call it as forward gain. So current gain wise we will get forward, voltage gain wise we will get reverse. So we can write here, reverse voltage gain we can write. Reverse voltage gain, which can be treated as 1 by AV we can write. Your current gain, you can write it as AI. You just add these 2 points. Current gain, you write an indication AI, but here HR, you can write it as 1 by AV. AV is called voltage gain of the transistor, and you make it reverse, it will become 1 by AV is HR, reverse voltage gain. And the last one we have is I2 is equal to H0 into V2. And what is H0 here is I2 by V2 is the value. So we got this as the final expression, H0. What is that telling? H0. It is not telling about impedance. It is not telling about impedance, it is telling about admittance. It is telling the reverse ratio of impedance. So we can write this as output. This is called output admittance we call. Output admittance, which is treated as 1 by Z0. It is an output impedance, a reverse word called H0. So like this we must have the 4 formulas in our practice to start the modeling of your BJT. Modeling will become very comfortable if you can learn these 4 parameters nicely in the board. So now onwards you should not have any doubt about these 4 letters because these are the 4 parameters we are injecting in the BJT model today. So let us have a small practice. Yes, Ayan, this is the first slide here. This is the first slide. I started now only. Just the first slide I am completing. So I think you came late. So you can copy afterwards. This is the first slide called hybrid parameters I am teaching. 4 parameters I completed. So note on it. We'll just move on to the next point. So there are 4 letters in the board which we never forget in the modeling. One is HI, one is HF, another one is HR, another one is H0. HI is telling about input impedance. You have to keep in mind. HF is telling about forward current gain. HR is telling about reverse voltage gain. And lastly, H0 is telling about output not impedance, it is output admittance it is telling. So I have this knowledge first. Yes, Advita, reverse ratio of impedance, we call it as admittance. Admittance. Okay? Reverse ratio of impedance, we call it as admittance we call. So please complete up to here. So let us move to the next slide. Okay, let us move to the next slide. After getting these four parameters, your input impedance, you got current gain, you got HR value, you got H naught, all these things we got. Now how to construct by these four parameters, how to construct a BJT model is our idea today, called H parameter model. How to do it, let us see. In the next slide, I'm showing that. In the next slide, I'm showing here H parameter model. H parameter model. This model, whatever I'm drawing here, can also be called as exact model. Exact model. So what this word means, exact? Today class we have two names, exact, approximate, like that, some terminologies will come. Anybody is considering all the parameters of two-port network theory, like HI, HF, HR and H naught, all the things you have considered in the model, we call it as exact model. If you are leaving some parameters, okay, from the model, saying that these are all neglected parameters, then it will become approximate. Approximate will do it afterwards. First exact model, how to do the analysis. It gives 100% accurate results. That is called exact model. Exact model, try to see. 100% accurate model is this one. So you have BJT like this with you. This is your BJT I have taken, bipolar junction transistor. And you have here two terminals, two-port network we can show like this. A BJT is also a two-port network. Now how to replace this model using this box, how to replace using hybrid parameters. How to replace this by hybrid parameter model. So if you want to replace it, first you can write this as V1, this as I1, this as V2 and this as I2. Just we'll replace that box by four parameters. How to replace, see the model. First in the box I'll take first as one letter called HI. I'll define HI in the input model. I'll create here one voltage source. I'll create here some voltage source. That voltage source, we'll write it as HR into V2 will write. This is your V1 and this is your current I1. This is called input modeling of your BJT. If you want output modeling, it will be current source you take. Current source. HF into I1. And write one parallel resistance here. 1 by H naught you represent that. And finally, you write the model with V2 voltage. Make a current here I2. So can you see the modeling, how he done it? Is there any trick for this? I'll explain. Trick also I'll tell you how to remember these models. I'll tell you small good tricks for it. This is the box I replace BJT. Now one box anybody can replace like this and you can study the amplifier analysis by using this model. This is called BJT box, where all the four parameters I just did in the model. This is called BJT model. This is called BJT model. So in the box, how I replace, what is the technique I followed, that I'll explain for you. So clearly see here, this is called input loop, this is called output loop. We have two separate models. Input model, input you write, output model you write output. In between, we should not show any contact between these 2 points because input have input, output have output. So these are the two different models where we have ground here as a common point. Top side don't contact, bottom side make it as a ground point. So total is common point. Okay. Then what is this story here? How I have written this model in the class is actually the trick here is you can see here you apply at the input one KVL. Here you apply one KVL and see what is happening. And you apply here one KCL, see what happens. Seeing the circuit, first input loop apply the KVL, output loop apply the KCL. What happens? If you apply KVL at input loop, can you see how the equation is being created? I'm applying a KVL at input loop. Then V1 is equal to I1 into HI, that is one voltage drop, plus HR into V2. You can see V1 is equal to HI into I1 plus HR into V2. Can you see that? This is your two-port network equation. This is your two-port network equation. That means nothing is there. Your two-port network input equation, I created like a circuit. That is a simple practice about your input loop, how to remember the practice. Your total equation is becoming a circuit there. And if you want KCL, suppose I applied here, another two-port network equation you can see. KCL, suppose at output loop I applied. KCL at output loop. If I apply KCL, this current is a division of two currents here. This is one current, this is one current. Two currents are there. Let us write the two currents. V2 is equal to HF into I1 plus HF into I1 plus, have you seen that? This is voltage by resistance is current. V2 by R2 will give the current. But V2 by 1 by H naught is your impedance, not H naught. 1 by H naught. Then if you reverse that answer, it will become H naught into V2. Can you see that? This is also a two-port network equation. This is also a two-port network equation. That means what is the logic? To create a model in BJT using hybrid parameter technique is one KCL equation, one KVL equation. You just try to understand it. That will become a model in BJT electronics. So that is the way how they created the hybrid parameter model. So this is one of the easiest model I can say in our life because only hardly these two equations, who knows, they can visualize this diagram. Okay, this is my exact two-port network model in electronics. It's one of the old theory actually, oldest theory. Hybrid parameter models we say this as. So writing a model is not a very tough actually. We can write input loop, you create like a KVL diagram. Output loop, you make it as a KCL diagram. So input you will say voltage source, output you will say current source. Output you will say current source, input you will say voltage source. Now some students will get it out here. Sir, these are all dependent sources. In networks course, we have studied dependent sources cannot be written like a circle. It can be represented like a diamond shape, correct? They try to represent like this. Dependent sources, we generally show like this. Dependent sources, we show like this. This is also a dependent source. So we have to show like a diamond shape. So then, sir, why you are not showing like this? You are showing just like a independent sources. Is there any reason for that? Means in analog course, please remember, in our two-port network theory, we don't have any independent sources. We have all dependent sources in the model. So whenever you have only dependent sources throughout your module, then you write circle, you write diamond, shape, nothing is bothering us. But in networks course, we have separately dependent sources in your circuit, independent sources. That is the reason why to distinguish dependent and independent, we'll write like that. But in analog course, we don't need like that. Whatever you like, you can write because all are dependent sources only in our electronics. That's why in exam point of view, some examiners will use like this. like this. So there is no difference. All are dependent sources only in our mind. Already we created it. So whatever you like, you can write in analog codes. But in networks codes, we cannot do like that because they are independent, dependent, two different sources. But these are all independent sources. Yeah, sorry, there is a small mistake. Some students have observed. This is not actually V2 here. This is I2. Yeah, by mistake I have written. This is I2. This I2 is equal to HF into I1 plus H0 into V2. Already, I think, who is that? Akshant. Okay. Ashish. Ananya. Okay. Yeah. So by mistake it happened. Just you can correct it. I2 is equal to HF into I1 plus H0 into V2. So up to here, I'm expecting you're happy to understand the module. Up to here, no doubt. Just whenever I say, is there any doubt for you, please message me that we don't have any doubts, sir. Then I'll proceed for the next step very happily. Okay. Up to here, if you're happy, then we'll go for the next step. Step by step, we'll increase the concept now. Up to here, I think you don't have any doubt. I'm expecting. We know the models now. Hybrid parameters, how to define it, and how to write the model. Up to that, we got the analysis. Very good. Roy here, actually, kya kiya, no? This current, whatever you're seeing, this current is suppose. You take this current as some Ix suppose. This current, if I want to write, how you can write current? Ix, if I want to write, it is voltage into resistance. Voltage by resistance, correct? Not voltage into resistance. Voltage by resistance. Therefore, resistance is here 1 by H0. Then what is Ix value? Here is, it is H0 into V2. This is the way how I got Ix. This is called, okay, great. Very great. So most of the students, no doubt, they are telling great. So this is the doubt some student got. Okay, right. I think this is the way you can, this is the way how I written that. Ix is equal to H0 into V2 we got. Because 1 by H0 is resistance or impedance. We converted into admittance concept. So till now, I think there is no doubt about this. So up to here, you are happy to understand the concept. So let us move to the next point. After getting this knowledge, what we can do in the class. Let us see the next concept. Next concept. Okay. So next concept we are doing is very important analysis called as transistor amplifier analysis we are doing. This is one of the important concepts to learn. Transistor amplifier analysis. In only one module we are studying the complete approach. Transistor amplifier analysis using exact model. By using exact model, how to study the complete behavior of the amplifier analysis. Right on this important topic today. Okay, important topic it is. Transistor amplifier analysis using exact model. So first point for the student, there is a small confusion. Transistor amplifier, he will think same. Transistor amplifier, he will think same actually. But in general, according to the knowledge which I have, transistor amplifier are different. That I want to show in the board to you. What do you mean by transistor? What do you mean by amplifier? What is the difference? Today I try to understand. This is the most confusion part for the students. Suppose this is your BJT device. This is your BJT. We have this as input port, this as output port. For any configuration, we have one input port, one output port. One we have a common port. This is a common port on both sides. Generally, we have only three terminals in BJT. Emitter, base, collector. Suppose you feel that this is a common emitter amplifier. I think this point is emitter points, where emitter is common. If it is a common base transistor, maybe this is base, where it is common for us, and the other two terminals will work like one is input, one is output, they will work. Okay? Okay. Satyam, if you read it, everything will come, don't worry. Okay? If you practice it, everything will come, don't worry about that. Because total content I have given for you. If any revision, if you want to do it, everything will get clarity. Okay? There is no meaning that there is no clarity in the concept, everything we got. Step by step you have to read it, you will get ideas. This is called three different configurations we can do. Common emitter we can do, common base we can do, common collectors also we can do it. The only thing is which is common, we'll keep here down, the other terminals we'll use. This is called as transistor, we call in electronics. This is transistor. This is called as transistor. This is called transistor. Up to here, you're enjoying transistor actually. But I want to make my transistor as an amplifier. If you want to make amplifier, what to do extra things? That is important. If you want to make an amplifier, what to do means there must be some input source you have to apply. There must be some load application should be there. All these things will come into the matter. So, okay. So input side, what we need is one voltage source is required. This is your voltage source. This is your voltage source. Which is it? Which is represented with a model like this. What this model is, which is nothing but microphone, electrical equivalent I have written. This is a microphone, which I am holding it in the classroom. This is called microphone. This is microphone. Electrical equivalent is like that. Voltage source in series to a resistance is the electrical equivalent of a microphone. If there is no microphone, there is no input to your transistor. That means the source which will come for the transistor is my microphone will be the input source. Okay? Microphone will be the input source. The next we have is output side, there is some load here. We are applying some load. We are applying some load arrangement. That load is nothing but loudspeakers. In the classroom, I think when you're in offline classes, I think not in this class, maybe in your BTech level or somewhere in auditorium, you'll see there will be speakers around your systems when somebody is speaking. Okay? If they are giving some seminar to you in the auditorium, there will be so many people will be there. So the voice will come very nicely because when you're sitting behind of you, there is a speakers. That is nothing but loudspeakers we say. Okay? In that we get a good audio power output. So there must be some output there called as loudspeaker. The loudspeaker is here. This is called loudspeaker. The loudspeaker has to connect to your transistor. I think we'll do these two things, connect to your transistor. This has to connect to this transistor and this has to connect to this. When you connect like this, then it will become, now you can say this will become an amplifier in the class. So this is the basic difference. First a student should understand. Before starting this course, a student at least has to understand what is an amplifier and what is a transistor. Because a transistor can again, suppose I'm asking you, then you have to teach only up to here. That's why today class I have to distinguish transistor characteristics will be different. And if I ask you here, from here to here, my gains, input impedances, output impedances, they'll be different naturally. So from the source, if you take, the impedances are different. If you talk from here, the impedance is different. If you talk from here, the impedances are different. So that is the differences between a transistor and amplifier characteristics. So in the exam point of view, the examiner what he is asking is main priority for me to answer the question. That's why I have the clarity on this concept, which will give a good indication to understand the subject. Okay? Transistor is up to here, amplifier is up to here now. From starting to ending is amplifier. So if you know this up to here, let us write the modeling. Let us write the modeling for this. BJT has to replace with the model is HI and a source. You can keep it ground here if you want. This is plus minus HR into V2. You take this as V1, this as I1, and this as V2, and this as I2. And your amplifier load current, you take it as IL. These are the indications you can do in the board. So the next we have is here current source HF into I1, and we have here 1 by H0. These are your terminals. This current is I1. This current is I2. This is your V1 voltage. This is your V2 voltage. Up to here, I created the model called BJT two-port network model. Okay? Two-port network model we created. Two-port network model you created. So you are talking about biasing voltage. Whenever you are talking only AC analysis, amplifier means what? AC analysis. We are talking only AC characteristics. This we should not talk here. Okay? Biasing, don't talk here because we are talking about AC part, not DC part. Previous classes DC part complete हो गया. अभी AC part analyze कर रहे हैं. So whenever you are doing AC analysis, we should not talk this concept. Otherwise you can write here we are talking about AC, not the DC analysis. At that time, why you are talking biasing here? So this is called AC model of your BJT. Whenever you write AC model of BJT, the next you have to interconnect this concept. We have RS, microphone I am connecting. This is your VS. And finally, we have some load here. This is your load. This is your load. Now you can see that interconnection how I am doing. From this point to this point, we have to interconnect. And this point to this point, we have to interconnect. This is your complete amplified model. You can see nicely how you can create yourself the models. Okay, nothing to remember. Most of the student does not have clarity on the subject. That's why they try to remember the things. But if the person is teaching step by step, I think we should not remember it. I'm expecting from you each and everything smoothly you do like this, how I'm doing in my board. Okay? So this is called amplified model in the class. So what is transistor? What is amplifier here? You can see difference now. This total is amplifier. If you teach from source to microphone to loudspeaker, it is amplified behavior. If you teach only up to here, this is transistor which transistor is only from V1 to only V1 port voltage to V2 port voltage. This is transistor. So V1 to V2 we call it as transistor, and VS to V2 we call it as amplifier. So there is a difference between these issues. Now let us define some characteristics now. First I'll define transistor characteristics, we'll do it. Transistor characteristics we'll find out. Then I'll come to amplifier characteristics. So we have to do total 2 jobs now. First the transistor characteristics we'll develop, next we'll come to the amplifier characteristics because both are different according to the board. Okay? Chandramohan, why you got the doubt here? Amplifier is modulator, why you are talking? Modulator is entirely different. Amplifier modulators are not same. Okay? Amplifier is different, modulator is different. Modulator is nothing but which we use for modulation techniques, correct? Where low frequency and high frequency we are going to superimpose them. This is an amplifier here, my friend. It's not a modulators. So don't interlink that and this. Or a mixer is subject verb. So amplifier main job is what? It will try to increase the power level of the signal. That is the main job of this amplifier, nothing more than that. Okay? So transistor characteristics will do it. The first characteristics I'm finding is AI. First characteristics I'm finding is AI. That is called current gain I'm finding in the board. Let's see how easily we can get the answers, exact model answers. Current gain means seeing the board you can tell. This is IL. This is IL. What is the relation you can write between IT to IL in the board is? You can have a relation here. Whenever you have IL, we can write it as minus I2. Because IL is your amplifier current direction. I2 is your two-port network current direction. So both have two different current directions. Generally, if anybody say current gain for a transistor, we should not say I2 by I1. Actually, you have to say IL by I1 because when you're sending some current will not come opposite to it. Current always go in forward. So generally, current gain means you have to tell now, according to transistor rule, you have to define it as simply IL by I1. This is current gain of your transistor. It is not I2 by I1, it is IL by I2 you have to write. So please understand it and observe these points. So what is IL here means, according to the two-port networks, we can change it if you want. Minus I2 by I1, you can practice it. Because you have indicated your current towards the box, but my current is going outward in BJT classes. When I'm sending some current, I'll send output current there. Okay, Chandramohan, no problem. Maybe in modulator how you studied, I don't know. So AI is equal to minus I2 by I1. Minus I2 by I1. So IL को हम लिख सकते हैं minus I2 we can write. I2 is a network's current, network direction it is. So let us write the current again with this knowledge. Can you tell me what is I2 current according to two-port network theory we studied? Suppose by chance you forget that current, why can't you see here and write a diagram is an equation and equation is a diagram for us. Now one knows. If anybody asks you what is I2, seeing the board you can write. It is HF into I1 plus H0 into V2. Seeing the diagram you can write. You're asking me I2 by I1 ratio in the class. Can you tell me what is V2 here in the board? V2. Your V2, can you write it as simply IL into RL you can write. Seeing the board. V2 you can convert IL into RL. Otherwise we can write this as minus I2 into RL. You can write as minus I2 into RL. Simply substitute this answer in your V2. Substitute this answer in V2. Then what is the answer we are getting is I2 is equal to HF into I1 plus H0 into minus I2 into RL. So this is the way how I substituted. Now can you see that you have only two current ratio now. I2 and I1. We can find out the answer. If you take I2 common, it will become 1 plus HO into RL is equal to HF into I1. You can see how much simple the derivations is very important. Or derivation is a concept. So I think we got the ratio. Completed my first calculation, exact model. So your answer is I2 by I1. Answer is RL. This is the ratio I can find from the second output equation. So we got finally the equation in the class. Yeah. This I2, what it is signifying, that we'll see afterwards. This is a generalized knowledge. It is not a common emitter, it's not a common base, it's not a common thread, it is generalized. After that I'll teach you. I2 represents what? According to the configuration, I2 will change. So there is only general analysis I'm doing first. You don't think this is a common emitter I'm doing. For any model you can do this analysis. Current gain is minus I2 by I1 you want. Just you want a negative sign extra. Okay. If you want a negative sign, the current gain can be written as minus HF by 1 plus HO into RL. So this is a very interesting formula which we create for exact models. So the first formula has been created like this by these experts. Minus HF by 1 plus HO into RL will be the exact answer for current gain. Taking two transistors can get amplified. Yes, Rahman, two transistors wise also we can get three transistors. That is called cascading we call. In the next classes there is a topic called multi-stage amplifiers, where we can cascade number of transistors to give more power gain. If I use only one transistor, we are not getting much power gain. If you use more number of transistors as a cascading, we can get more power gain. So amplifier means with one transistor I can do it. I can do with the 10 transistors, I can do with 100 transistors. That is my wish, according to the application. Okay, first initially we are studying about one transistor in the class. So why can't you hit this formula in your mind? About one transistor in the class. So why can't you hit this formula in your mind? This formula is a very golden formula, I can say, for hybrid techniques. If anybody forget this formula, why can't you have this approach? Seeing the diagram, your approach is very easy to get the answer. Okay? So answer is minus HF by 1 plus HO into RL. That is the first formula. So please complete up to here. Concept number 1 is ready. So I'm thinking you're writing parallel with me. So write neatly up to here, concept. Just take some water. Meanwhile, take up to here. So up to here, I think you've been complete. Next we'll see the concept number 2, that is called input impedance. How to solve? Next parameter. Next parameter, we are going for input impedance. How to solve in the concept? Can I expect all the students have been copied? Are you ready for the next derivation? Next derivation, are you ready? Writing is completed. Satyam Prakash, इधर confused नहीं होना यार. Suppose I1 से current send किया मैं BJT में. I2 current will not come opposite to me. It will deliver to the load output. That's why output current in transistors we have taken as load current as IL direction, but conventional direction is I2 kept inside from the network theory. That's why I just modulated two networks, saying that the sign is opposite. Okay? Networks course me, that block does not have any meaning, but in BJT, that box became a BJT. So whenever you send some current inward, the current will deliver output. That's a common sense. Okay? So Partha Saradi here, V2 0 क्यों कर रहे हो आप? V2 0 क्यों कर रहे हो? V2 0 is a word we have used in the class when you're finding the parameters. After finding the values, we kept the load. So you should not take V2 0 at this moment. V2 0 is a concept we applied for previous cases to understand each parameter knowledge. Okay? इधर V2 क्यों 0 कर रहे हो? Yes. Next we'll see the step 2. Step 2 is concept number 2 is input impedance. Input impedance. Input impedance, how to find? Called Jedi for a transistor. If I write Jedi for a transistor, it is V1 by I1. Only I am teaching for transistor input impedance. V1 by I1 because V1 became the input of your transistor. I1 is your input current. So write down V1 by I1. You just write down parallel with me and finish up the mathematics. V1 by I1. But we have V1 knowledge. V1. Input KVL if you apply. What is V1 here is? V1 is equal to HI into I1 plus HR into V2. Just this is a KVL of my input circuit. If you don't remember, you just write KVL of your input circuit. This is an input KVL circuit. Just what I'll do is, I'll just divide V1 by I1 in the class. It will become HI plus HR into V2 by I1. Just I divided both sides with this knowledge. Now can you see what is V2? We have understood in the class is, it is minus I2 into RL from previous derivation. V2 is nothing but minus I2 into RL. So V1 by I1, we can take it as Zi is equal to HI plus HR into, so we can write it as minus I2 by I1 into RL. So this formula, just I kept in V2. So can you see the answer is completed? Your input impedance formula is HI plus HR into AI into RL. So this is the formula for Zi. So how the formulas are coming, you can see. Just hardly, first derivation I have done with output loop, second derivation I have done with input loop, my answer is complete. This is the way how to remember the techniques. So by chance if you forget the subject, that your circuit will tell you the answers straightforward. So this is my exact answer. You felt that previously HI is your input impedance, but in exact model, it is not only HI, we have some extra quantities there. HR is there, current gain is there, load is there, it is depending on all these parameters. Okay? So then sir, why you found current gain first? Next input impedance means current gain is a parameter which will influence your input impedance. So first that is the reason in exact model there is an order of study. First the current gain I solved, next I came to input impedance. Okay? The next we have is concept number 3. Concept number 3 is voltage gain, how to find? Voltage gain. Voltage gain, we call it as AV, is the next step. Step number 3. Voltage gain we are finding for the transistor. Voltage gain we are finding. Voltage gain, if you want to find, can write AV is nothing but V2 by V1. Output voltage by input voltage of your transistor, not amplifier. If I say amplifier, you write VS, source voltage, but it's a transistor, so up to V1 we are finding the voltage gain. But you know what is V2 here? V2 is nothing but minus I2 into RL divided by V1. Just I apply this formula again. Minus I2 into RL is nothing but V2. So in all the derivations, V2 knowledge is minus I2 into RL. I am applying. So this ratio shall we make minus I2 by I1, I'll divide V1 by I1, I'll divide into RL, I'll write. Can I see the top and bottom? I have equated the same current, I1, I1. So this ratio is nothing but, AV is equal to, this ratio is nothing but current gain into load divided by, this is called input impedance. Have you understood the secret of the concepts? Voltage gain, why it is coming as a parameter number 3 is voltage gain is depending on input impedance of your system. It is depending on your current gain, then voltage gain is coming. That's why first the current gain I solved, next input impedance, next voltage gain. This is the order of finding your transistor characteristics in hybrid parameter model. So this is a simple way of studying the concept. And the fourth one, we have the last parameter called as output impedance. Output impedance, which is called Z0. So one thing please remember, output impedance is very important calculation for the amplifiers. In networks course, I think you studied or not, already syllabus is complete or not, I don't know. But output impedance has a general common rule for us. In Thevenin's theorem or Norton's theorem, you'll study this. There are two important rules for that. What are the two important rules is conditions. You should be applied every time these conditions. Conditions. To find out the output impedance, they kept some two rules. One is load should be infinite. Load should be infinite. And your voltage source, what you kept at the input should be 0. These are the rules. For input impedance, we don't have any rules. Straightforward, you get the answer. But output impedance, there are rules. If you are solving from output to input, suppose impedance, input there is a voltage source, you have to make it short. If there is a current source, you have to make it open. Then you have to find out the R equivalent resistance. That is your R naught. So here, voltage source you have to make it 0 because you are seeing from output to input. There is a voltage source Vs. Okay, then you have to make it 0. And the load should be infinite. So what is the meaning of this? I'll show you one time. See here. You are seeing from here the output impedance, correct? Then why you require RL there? RL is unwanted for you. That's why RL go open karo. Just remove this because you are finding before this the output impedance. And when you are seeing from here the output impedance, are you seeing that there is a voltage source is coming there? Actually, you want to teach up to here on the model, but when I'm seeing from here, I'm seeing the voltage source there. So that's why voltage source we have to make it short. These are the two basic things we have to apply. Okay, that's why. Right, networks never no problem. That's why I'm teaching fundamentals for you. Okay, fundamentals I'm teaching in networks. So this rule will apply for everywhere. So RL equal to infinite, you apply for every question. In the next class is whatever the output impedance I solve, I'll apply this only every time. Voltage source you make it as 0. If you make voltage source 0, how the model looks for you? It looks like this. The total model looks like this. You will have a short here. Your Vs became 0. Next we have is Rs. Next we have is Hi. Next we have source HR into V2. This is V1 and this is your I1. Okay. Next we have a current source HF into I1. Next we have is 1 by H0. The load should be open. So we are finding the output impedance from here. So this is why you are solving the problem. Your load RL you made it as infinite. Your RL value you made it as infinite here. So just open the RL and input voltage source should be short. This is the method which we use to calculate the output impedances. It's not a big task here. It's not a big task, simple thing. Okay. A short karo, but the load open karo. Then what is the output impedance if I want to solve from here? So I can write this as a V2. This is V2 voltage I'll take, and this is your I2 I'm taking. So Z0 we can write it as V2 by I2 we have to take. This is Z0. V2 by I2. Okay. V2 by I2. Satyam Satyaprakash. कितने बार बता रहा हूँ यार? Again you are asking क्या conditions है? क्या बोल रहे हो? Output impedance calculate करने के लिए there are two rules. RL को infinite करो and input source को short करो. Diagram भी लिखना उधर. So what is the meaning of asking again? Please explain the conditions. Okay. So when you're finding from here, load is not interfering your concept. That's why he said that load को हटाओ. First point. Load remove करो, which is not influencing your problem. And input sources whenever you cannot find out the impedances correctly. So voltage source को short करो. If there's a current source, suppose you have to make it open. These are basic rules he's telling. Okay. Simple things there. So nicely I have written step by step here. Then you should not get the type of confusion. Again you should not ask repeat. Okay. So V0 is equal to V2 by I2. But here the problem is V2 we have written the formula as minus I2 into RL we are writing till now. But to calculate the output impedance, RL go infinite conditionally up. So V2 expression has gone up. We cannot find V2. That means V2 became unknown in the class because RL is infinite you have taken. So we cannot take that formula. That's why what I'll do is why not I'll find out. That is I2 by V2 will do it. As we cannot find Z0 by V2 by I2. Okay, we are finding it by I2 by V2 first because this is unknown now. Because load is infinite you have taken, V2 we cannot find directly. So that's why first this expression we'll find out. But what is I2 here is I2 if you want always the trick is KCL you have to apply here, same equation. That is HF into I1 plus H0 into V2. HF into I1 plus H0 into V2. And divided by V2 you just divide it. Can you see that? V2 is cancelled. So only we have this term. I1 by V2 is the only term we have to find out there. But I1 will come from input loop. I1 will come from input loop. I1 by V2 will come from input loop. Just apply KVL from input loop. 0 is equal to I1 into RS plus HI plus HR into V2. Just apply the KVL. After applying this condition, Vs equal to 0. Just apply the KVL lines. And you can say that sir, I1 कितना sir means V1 voltage है. Okay? Vs is 0, not V1 is 0 there. So 0 is equal to I1 into RS plus HI plus HR into V2. This is the concept. So can we find? Shah here RS क्यों consider कर रहे हैं आप means you're finding from output you have to see from the source. Okay, you are telling V1 तक ये teach कर रहे हैं, but I'm seeing the complete circuit. That's why if you are seeing from output, RS also will come into the influence. But if you start thinking from here, this will not come into the matter. You are talking input impedance from here. That's why ये matter में नहीं है आपको. But when you are talking from output, load is not coming into the matter. Like that you have to visualize the diagram concept. Okay? When you see from output to input, RS will come natural. HR by HI plus RS. So this is the way how I found this ratio I1 by V2. So finally, what is Y naught? You can easily write down now. What is Y naught? Y naught formula is H naught, first you write H naught plus HF into minus HR. HF into, so this is HF. This is HF minus HR divided by HI plus RS. So this is the formula we are getting. Then what is Z naught here is, it is 1 by H naught minus HF into HR divided by HI plus RS. So this is somewhat you'll see lengthy formula, but derivation you must be able to understand it so that getting this formula is not a big issue. Okay, only the methodology you have to understand. Procedure is very important. Whenever you forget it, you will get it automatically. Load is open Hampton, your input source goes short here, where the concept is clear. So the formula is 1 by H naught minus HF into HR divided by HI plus RS is the output impedance of this two-port network theory analysis of your transistor. So these are the four beautiful parameters. These are the four beautiful parameters we can solve it. Without having much pain, we can solve it. They're not taking much pain for me to teach these four derivations. Very beautifully, trick-wise, you can solve these questions. So these are my package of four characteristics of your transistor. Okay? Yeah, sure. You understood? Very good. So these are my parameters up to here. So input impedance we calculated, current gain we calculated, input impedance is calculated, voltage gain and output impedance. Nicely, these four calculations should be in practice always. Okay? This is the standard knowledge which you can practice. So in exam point of view, most probably exact problems they will not ask you. They'll go for approximation techniques. Exact is only a chance of asking 5% to 6% chances are there. At that time, you should have this great knowledge to answer the question. Otherwise, if you don't have standard exact answers, we cannot teach approximate now. Approximate if you want to understand, if you want to engineer 95% of your problems, exact formulas equal understand karna. That's why each and every derivation I've shown in the class. Each and every step also. Very carefully I'm explaining the points. Why there are not any condition at input impedance like output impedance? Shabani thus generally networks, if you study the classes, you'll understand the main principle. Why input impedances will not have, why output impedances will have, this basics you'll understand well. Because my input current, whatever you have given, see here the logic, whatever the input current you have given, it has been transferred to the ground like this. The input current is going like this. But actually, whatever the current is coming here, this became an input loop for you. But whenever you calculate from the output, this total responsibility is coming from output to input, it is depending. The total picture is depending. But when you're solving input impedance, okay, the input loop itself is telling the input part. Because output will not come into the input part. But from output, when you see, it will come to the input part also in the concept. So the difference is that when you see from here, we are not bothering this one. Output we are not bothering, because only input loop circuit we want. But when you are solving from here, it's depending on V2, which is coming the total impact up to here. Okay, it's coming the total impact. So that is the basic rules. Maybe with examples you can study in networks courses. At this point, please understand input impedance when you solve, only input loop is enough to solve it. But when you solve the output impedance, you have to take from output to input. Total analysis we have to do it. If it is not clear, you can understand that course in the networks. There you will get a good idea. Here I don't want to teach all the stories. So I think here I'll stop the class. Hybrid parameters is not completed. We'll take a break and continue from here the class. Okay. This will be the first basic module. First we started the hybrid parameter techniques. Next after the break, we'll try to see how to do this analysis in amplifier topic. We have studied transistor now. We'll convert it to amplifier calculations. And finally I'll prove that amplifier